Assalamualaikum warahmatullahi wabarakatuh. My name is Norifah Iliani binti Zuraini. I am here to present about assignment 3 from article which is detection of earthquake-induced landslides during the 2018 Kumamoto earthquake using multi-temporal airborne LiDAR data. For the introduction, what is earthquake? Earthquakes are the sudden release of energy due to rupture on faults and fractures. The stress released as energy during the rupture has been accumulated due to plate activity or volcanic activity. Earthquakes can have a wide range of direct and indirect impacts, including loss of life, damage to public and private properties, and infrastructure, as well as tax impacts arising from recovery and reconstruction expenditures and decreased tax revenues. How do earthquakes affect the atmosphere? The atmosphere, according to the Oxford Dictionary, is the envelope of gases surrounding the Earth or another planet. Earthquakes affect the atmosphere because gas emission from ground release toxic gases that are released into the atmosphere. It creates dust, debris, and gas emission released from the ground. These toxic gases to the atmosphere which add to the air people breathe from. For the real cases, many people had died in the Haiti earthquake by polluted air and being unable to breathe. It is estimated that this polluted air has killed 64,000 people the year of 2010 Haiti earthquake occurred. This and remote sensing for earthquake studies. In this study, two sets of the pre- and post-event airborne LiDAR data were applied to detect landslides along the Futagawa Fault. The results were verified using truth data from field servers and image interpretation. The pair of digital surface models acquired over a short period and the pair of digital terrain models acquired over a 10-year period is used to detect landslides. The objective of the article is not only to detect landslides, but also to compare the performance using two different sets of LiDAR data. The study area is at the Mashiki Town and Nishihara Village, Kumamoto Prefecture, Japan. For the data used is two sets of pre- and post-event airborne LiDAR data. The raw point clouds have been resampled in 50 cm meshes. This data set had been used to estimate the seismic displacement and detect collapsed buildings. The aerial photo and transform data image of LiDAR data, ortho image, digital surface model DSM image with 1 meter spacing, and digital terrain model DTM image of 2 meter spacing. Next is LiDAR. LiDAR, which stands for light detection and ranging, is a remote sensing method that uses light in the form of a pulse laser to measure ranges, which is variable distance to the Earth. This light pulse, combined with other data recorded by the airborne system, generate precise 3D information about the shape of the Earth and its surface characteristic. LiDAR can produce more accurate shoreline maps, make digital elevation models for use in geographic information systems to assist in emergency response operation like earthquake and many more. About the methodology, the article said that the attempt to detect landslides using the DSM acquired on 15 and 23 April 2016. Using a simple trace holding value of 2 meter, the landslides were detected with much noise. Thus, we improved the method by adding the topographic features. As we can see, this is the article methodology. And then, for the result and discussion, from the DSM acquired on April 15 and 23, 2016, 110 regions were detected to be landslides. Most of the extracted results were located close to the Futagawa Fault. According to those comparisons of the detected results with landslides identified by NID and IED, the two temporal DSM acquired in a short period are sensitive for detecting landslides, and the results were affected by trees. When the two temporal LiDAR datasets were taken over a long period, DTM are more suitable in landslide detection. In this study, the low point density of the pre-event LiDAR caused the low resolution of the DTM. Small landslides could not be detected by our approach. However, the proposed method would work better using high-density LiDAR. This is the result. For the last but not least, the conclusion. In estimating the cosmic displacement, the DSM acquired over a 10-year period were found to be unsuitable for detection due to presence of significant surface changes. The DSM were more sensitive than the DTMs for detecting small landslides. However, the DTM results were more stable compared to the DSM result. Higher resolution DTM can improve the detection accuracy. Since GSI conducts LiDAR surveys on a regular basis, the proposed method can be applied when the post-event LiDAR data are available.